Hello, this is Mr. McAllen. Hello class. Today I want to go over some substitution problems just as a review. So the first one we're going to do will be a basic substitution, and then we'll move on to a medium one, and then we'll do a substitution with limits. This is just to remind you about what we did in class, and hopefully this will help you refresh your memory and do the work that we have assigned for today. So if we have an integral that's indefinite, and it has it looks like there's a function, an inner function that can simplify the integral. We'll try a substitution. So we'll say let's let the u substitution be t squared plus 5. Remember, the key thing we're looking for is, does the function we choose when you take its derivative have something to do with what's left over? And when we analyze this and take the derivative, du equals 2t dt, and we notice that that t function is what's in our numerator, and we have a feeling that this substitution may work. We then go on and we solve for dt, and then we use this as our value to plug back in for dt when we convert our integral completely over to a u integral. So I'll leave the t in from the beginning. I'll replace the t squared plus 5 with a u, and my dt will now be replaced with du over 2t. When I simplify that integral, I end up having just an integral of the form of the natural log, du over u, which results in the natural log of the absolute value of u plus a constant, and then I just back substitute in t squared plus 5 as my answer to this integral. Okay, and here we have our second substitution integral. This is a little bit harder, but we have to look for an identity. So the first thing we want to check out is, do we have an antiderivative for the cotangent of 3x? And we don't. We can take its derivative, but we don't have an antiderivative that takes us back to the cotangent of 3x. So what we're going to do is we're going to look at trig identities, and hopefully you remember the quotient identity for cotangent is the cosine of 3x over the sine of 3x. We're going to make a u substitution, and I'm choosing u to be the sine of 3x because when I take its derivative I will get the cosine in the numerator. Unlike if I chose a cosine, I would get the negative sign in the numerator, but my sine is in the denominator, so that tells me that this would be a better choice. So my differential du will be, from the chain rule 3, cosine of 3x dx, and I'll just solve for the differential. And then I proceed along, and I'm going to make my replacements. I have cosine of 3x, which was there before. It's going to be over u, and my dx term is going to be replaced with du over 3 cosine of 3x, and we see that that cancels with that. And we have a nice easy integral, which will be, bring the 1/3 out in front, the integral of du over u, which could also be written as the integral of 1 over u du. It depends on how you write it, but the same answer, and it will be 1/3 the natural log of u plus a constant. We back substitute, and we have 1/3 the natural log of the absolute value of sine of 3x. If we take the derivative of this, because that's our answer to the integral, just to check, you should always check the derivative of 1/3 natural log of sine of 3x is 1 over sine of 3x times the derivative of the inner function, which is sine of 3x, which will get cosine of 3x times 3. And when you look at that, the 3's will cancel, and we'll be left with what we started with. It was cos of 3x over sine of 3x, which is the cotangent of 3x. So we'll move on to the third problem. Let me just write it up, and then I'll return. Okay, we're back, and now we have an integral with limits, and I just want to point out that these are x limits. These limits, it says to find the area under the curve of e raised to the tangent of x times secant squared of x, and it says to do that between the upper limit of x being pi over 4 and the lower limit of x being 0. So what we're going to do is we're going to do a trig substitution. We're going to switch domains, so we'll say let u equal tan of x, and then we take our differential. Du is equal to secant squared of x dx. We solve for dx as we've done before, but now we have to switch our domain values as well. We're going to change the domain, so the upper limit of being pi over 4 for x, I'm going to say, well, u, if I plug in tangent of pi over 4, the upper limit will be 1. I should know my tangent ratios by now. And my lower limit will be, if I plug in the tangent of 0, that should be 0. So now I'm doing the simple integral on the u in the u domain, where I'm going to replace my tangent with a u, and my secant squared will stay there, but when I replace my differential term with du over secant squared of x, I've converted the entire limit over to u limits and a u integral, and I have the exponential function u du from 0 to 1, which is a nice easy integral to solve, which will just be e to the 1 minus e to the 0, which is going to be e minus 1. Hopefully this video has helped refresh your memory on how to apply some properties of substitution method, and I look forward to your comments. Please like this video if you found it helpful, and subscribe to this channel. Take care.